Hello everyone, today let's solve the problem number 48, rotate image, right? So what the question states here, we are given an n into n integer matrix. See here, we are given an n into n integer matrix on the example 1 and example 2 as well, right? So we are given an n into n integer matrix, so this one is 3 into 3, right? So we have to rotate it 90 degree clockwise and place. They have strictly mentioned 90-degree clockwise in place, right? So we have to modify the input, no extra 2D matrix has to be used, right? So we have to do the change using the math or the geometry trick. So that's what they have given in the question, meaning no allocation of the another matrix. We have to return nothing. The input matrix itself must become the rotated image. So that is the main thing. See here, we have 1 2 3 4 5 6 7 8 9. See here, when we rotate this one, so this one 1 2 3, we have this one, what do we call 1 2 3. So when we rotate this one 90 degrees, so this 1 2 3 comes at the last column, right? So this one 4 5 6, this 4 5 6 comes at the second column, and this one 7 8 9 comes at the first column, 7 8 9, right? So same thing goes with this one as well, man. See, 5 2 13, this one 5 1 9 11 comes at the last column, 2 4 8 10 comes at the last but one column, nothing but the third column. This one 13 3, this one 6 7 comes at the second column, and finally 15 4 12 16 and comes at the first column. So this is fine, the same output that we need to return. So they have strictly mentioned what they have mentioned. So we have to rotate this one 90 degree in place. So we have to modify the input, no extra 2D matrix. They have strictly mentioned here. This is fine, man. Right, this is fine. Now let's do one thing. So let's discuss the approach followed by the complexities, and then let's write the code. Right, first let's discuss the approach. Right, so we'll just go with the geometric approach. Right, so simple geometric approach. Just give me a second here. Yeah, let's consider the same first example here. Just 1 second. So this one, first example here, this one, let's consider the same thing, this one. So first what we'll do, we'll transpose across the main diagonal, meaning we will swap ij with ji, right? So first what we will do, we will transpose across this one, what do we call main diagonal. We will swap ij with ji, right? So we will swap ij with ji. This is fine. Now after transpose, this one will be 1 4 7. This one comes first basically. So this one will be 1 4 7 followed by this one. Next comes the 2 5 8 basically, right? So this one will be 2 5 8. So next one will be 2 5 8. So this one I'll just mention like this, 2 5 8. Finally we'll get 3 6 9, right? So this part finally we'll get 3 6 9. So this is fine. This is fine. We are done with 1 4 7 2 5 8. This one finally 3 6 9. This is fine, man. Yep. Yep, this is fine. So here geometric meaning, so we have to reflect the matrix over the main diagonal, that is nothing but x equals y line, right? So this is fine. Now let's reflect horizontally. We have to reverse the each row. When we reverse the each row, so see here we have 1 4 7. So when we reverse this one, we get 7 4 1, right? We get 7 4 1. This is fine. Previously we were transposing across main diagonal, right? So now what we are doing, we are reversing the transpose matrix. We have already got the matrix here, this one transpose matrix. Now we will reverse this one. This will be 7 4 1 followed by 2 5 8 becomes 8 5 2, right? 8 5 2. This is fine. And finally we get this one 3 7 9 becomes 9 7 3. This one becomes 9 7 3. This is fine, bro. This is fine. 9 7 3, sorry, 9 7, or this is 9 6, right? Sorry, 9 6 3. This is 9 6 3. Now we have 7 4 1 8 5 2 and the 9 6 3, right? After reversing the each row of the transpose matrix, right? So we are just mirroring the transpose matrix left to right, right? So this is the output that we got. So output that we got here is this one, 7 4 1 8 5 2 and 9 6 3, which is equivalent to the output that they have mentioned for the example 1 within the question. So this is the idea basically. We'll be doing the same thing, I mean we'll be articulating the same thing in the form of code, right? So why this is equal to 90 degree clockwise rotation? Because we are going with a coordinating mapping, this one for the 90 degree clockwise rotation. That is nothing but I comma j equals j comma n minus 1 minus I, right? So we will be transposing the swaps I comma j with j comma I, and we will reverse each row that implements the n minus 1 minus I shift, right? Basically combined they produce the mapping that is above, right? So this one basically 741852963 that we got, right? So this is the approach that we'll be going with, mainly simple geometric approach, right? So this is fine. Now let's do one thing. As we know the approach, let's quickly discuss the complexities and then let's write the code. So what will be the time complexity here? Just give me a second here. So overall time complexity would lead to big O of n square, right? So overall time complexity would lead to big O of n square because we visit or swap each element a constant number of times, nothing but transpose plus row reversals, right? So we are going with so this one overall time complexity would lead to big O of n square. So what will be the space complexity here? The space complexity would lead to big O of 1, right? So the space complexity would lead to big O of 1, right? So this is in place swaps only using a constant amount of extra space. This is nothing but temporary, nothing but TMP, the variable that we'll be making use of. Simple, this is fine. So overall time complexity and the space complexity for the code that we'll be writing in the future would be big O of n square and big O of 1 respectively. Now as we are completely familiar with the approach and the complexities, let's start writing the code, right? So the first thing is let's get the matrix size and nothing but n into n, right? So let me assign this one to n, matrix dot length. So let me copy this one, matrix dot length. So this is fine. Now let's transpose the matrix in place, meaning we have to swap the matrix of ij with the matrix of ji. So let me go with for loop here. This is fine. Int I equals 0. So this one has to be I less than n, I plus plus. So again for j equals, oh I forgot int here, j equals I plus 1, j less than n. So this one has to be j plus plus. So this is fine. Within the for loop, what we'll do, we'll temporarily store the element. So within the for loop, what we'll be doing, so we will temporarily store the element at I comma j. So this one will be temp. So let me assign this one to matrix of I j. This is fine. So next let's move the element from j comma I to I comma j. So this one will be matrix of I j. So that this one will be I have copied the matrix, right? So this is fine. Sorry, let me type instead. Matrix of j I. This is fine, man. Now let's put the stored I comma j value into the j comma I. So this one will be matrix of I. This one will be matrix of j I. Let me assign this one to the temp. This is fine. So let me come out of this one entirely. Now what shall we do? Let's reverse each row, right? So we have to reflect this one horizontally, the second step if you remember, right? Just to complete the 90%, 90 degree clockwise rotation, right? If you remember the second step that I showed within the approach, the same thing. Let's reverse each row that reflects horizontally basically. So I'll just go with the two for loops again. So this one will be int I equals 0, I less than n. So this one will be I plus plus. So within this for loop again one more for loop. So this one will be int j equals 0, j less than n, j. This one has to be n by 2. So this one will be j plus plus. So within the for loops, so let's store the left element. So this one will be temp, this one matrix of I j. This is fine. So let's move the right element to the left. So this one will be matrix of I j equals matrix of I, this one n minus 1 minus j. This is also fine. The next one would be, we have to put the stored left element to the right. So this one will be matrix of this one I n minus 1 minus j. This is also fine. Let me assign this one to the temp. So this is fine. This is it for the code. Let me format the code once and let me hit the run button. So I hope this works. Let's see.
Hello?
Yeah, this works for the sample test cases, right? So let me hit the submit button quickly.
ನಮಗೆ ಬ್ಯಾಂಕಿಂದ ಇ ಪಿ ಎಫ್ ಅಮೌಂಟ್ ಬಂದಿರಲಿಲ್ಲ.
So here you can clearly see all the test cases are getting passed, meaning this one, our code, whatever the code that we have written works absolutely correct, right? So whatever the code that we have written works absolutely correct. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.